Hello, in this lecture we will find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that AE is equal to ED, and we also know that EB equals to 7 units, BF equals to 9 units, and also angle ABE is equal to theta, and angle EBF, this angle is also equal to theta, and we want to find out the area of this green shape. Okay, so we will start with the first method. In the first method, we will extend BE and CD until they intersect with each other. So we will start and we will extend side CD of rectangle ABCD by a straight line. And we will also extend BE. We will extend side BE until it intersects with the extended CD. And we will define the intersection point between extended BE and extended CD as point P. This point will be defined as point P. And we know that side CD of rectangle ABCD is absolutely a straight line, and we extended the straight line CD by a straight line, so CP will be still a straight line. So we can write down that CP is a straight line because we extended the straight line CD by a straight line, and we got line segment CP, so CP will be still a straight line. I will write it down. CP is a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So I'll read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay? And we also know that all the angles inside the rectangle are right angles. That is to say, they are equal to 90 degrees. So this angle is a right angle, it equals to 90 degrees. This is also a right angle, it equals to 90 degrees. And this angle is also a right angle, that is to say, it equals to 90 degrees. And we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on this side of the straight line PC, then at point D, this point, the sum of the angles must be equal to 180 degrees. So this angle PDE, that we will define as angle X, plus this angle that is a right angle because it is 1 out of 4 angles of rectangle ABCD, therefore it is a right angle. The sum of those two angles must be equal to 180 degrees according to rule number 1. So I will write it down. Angle X plus the angle that equals to 90 degrees, the sum of them must be equal to 180 degrees according to rule number 1. Okay? So we will subtract 90 degrees from this equation and we will get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle. That is to say, it equals to 90 degrees. So we can substitute angle X by right angle. Angle PDE, this angle X is equal to 90 degrees. And we know that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DC. And we know that CP is one straight line. So if AB is parallel to the straight line DC, then AB will be also parallel to the same straight line CP. Okay, AB is parallel to CP. You can write down that AB is parallel to CP or PC. AB is parallel to PC, and those two angles, they are defined as alternating angles, and they are located between the parallel lines AB and PC. And according to rule number 2, they are equal to each other. I will write down rule number 2. Rule number 2 states that alternating angles between parallel lines are equal to each other. I will read rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. So here, those two angles are defined as alternating angles. That is to say, angle ABE and angle EPD are defined as two alternating angles, and they are located between the parallel lines AB and PC, therefore they are equal to each other. So we can write down that this angle ABE, equals to this angle, that is angle APD, and they are equal, angle EPD, and they are equal to each other according to rule number 2 that says that alternating angles that are located between parallel lines are equal to each other. I will repeat again, angle ABE and angle EPD, they are two alternating angles that are located between the parallel lines AB and PC, therefore they are equal to each other according to rule number 2. Okay? But it is given us in the question that this angle ABE equals to theta. Okay, angle ABE equals to theta, so we can write here that angle ABE equals to theta according to what is given us in the question, and from this equation we will derive that angle EPD, angle EPD also equals to theta. Angle EPD also equals to theta. angle EPD equals to theta. In the next step, we will conclude that those two right triangles congruent to each other. Okay, so we will conclude that triangle, the green right triangle, triangle ABE, this green right triangle is congruent to this right triangle, triangle EPD. So why those two triangles congruent to each other? First of all, we have those two angles. We just right now proved that those two angles, they are equal to each other, they are both equal to theta. So we can write down that angle ABE of triangle ABE is equal to angle EPD, this angle, and both angles are equal to theta, as you can see from the drawing. So we found out that angle ABE equals to angle EPD equals to theta, according to what is given us in the question. Angle AB equals to theta. Okay, and we have also those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE of the green triangle is equal to angle PDE and they are both equal to 90 degrees. I will repeat again. Angle BAE equals to angle PDE and they are both equal to 90 degrees. And those two angles, they are also equal to each other. There are two vertex angles, and we have a rule that states that vertex angles are equal to each other. So this angle, angle AEB, is equal to this angle, angle PED, and they are equal to each other. Those two angles are equal to each other according to the rule that vertex angles are equal to each other. I will repeat again. Angle AEB is equal to angle PED according to the rule that vertex angles are equal to each other. And we also know that AE is equal to ED AE equals to ED according to what is given us in the question. So I write it down. AE is equal to ED. It is given us in the question. I will repeat again. AE is equal to ED according to what is given us in the question. So we actually proved that those two right triangles can congruent to each other according to angle side angle rule. I will write it down. So actually triangle, the right triangle, triangle ABE, right green triangle, triangle ABE, this triangle is congruent to, so this is the sign of congruent. The right green triangle, triangle ABE is congruent to the right triangle, triangle DPE, and they congruent to each other according to angle side angle rule. I will repeat again. Triangle ABE, the right green triangle, is congruent to the right triangle, triangle DPE, according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that I will write down the rule. Angle side angle rule says that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle then the triangles congruent to each other according to angle side angle rule. So I will read the rule again. Angle side angle rule states that if two angles and the side that included between those two angles and the side that included between those two angles I'll read it again. Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles congruent to each other according to angle side angle rule. So, and in our drawing we actually proved that those two angles and side AE that included between those two angles in the green right triangle ABE congruent to those two angles and the side that included between those two angles, that is to say side ED in the right triangle PED. Therefore we proved that those two triangles congruent to each other according to angle side angle rule. Okay? We have those two angles and the side that included between them, that is to say AE in the right green triangle AEB congruent to those two angles and the side that included between those two angles, that is to say ED in the right triangle PED. Therefore we prove that those two right triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. BE equals to EP. I'll repeat again. From the fact that the two triangles congruent to each other, we will conclude that BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say BE and EP, will be equal to each other. That is to say BE equals to EP, but we know that BE equals to 7 units. BE equals to 7 units. It is given us in the question that BE equals to 7 units. So we can write here that BE equals to 7 units, and from this equality we will conclude that EP also equals to 7 units. EP equals to 7 units. So we can write here that EP equals to 7 units. In the next step, we will define the area of this quadrilateral EBFD is Y. I repeat again, the area of this quadrilateral EBFD is defined by us as Y. The area of quadrilateral EBFD is defined as Y. Actually, those two brackets is the sign for the area, so it means the area, here I'll write it again, the area, those two brackets are the sign of area, so the area of quadrilateral EBFD is defined by us as Y. So the size of the area of quadrilateral, the green quadrilateral EBFD is defined as Y. And we will define the area of triangle ABE, the green triangle, as X. So the area of triangle ABE, again, this is the sign of the area, the two brackets. So the area of triangle ABE, the right green triangle ABE is defined as X. And the area of the green shape is equal to X plus Y. X plus Y is the area of the green shape. So I will write it down. The area of the green shape that we are looking for is equal to X plus Y. I will repeat again. The area of the green shape that we are looking for is equal to X plus Y. But because of the fact that those two triangles can congruent to each other, they also have the same area. And because we defined the area of triangle ABE is X, then the area of triangle EPD will be also equal to X, because they can congruent to each other, therefore they have also the same areas. Okay, so the area of the right triangle EPD is also equal to X, and the area of triangle BPF, the area of this triangle BPF, is also equal to X plus Y. I will repeat again. The area of triangle BPF is also equal as X plus Y, exactly as the area of the green shape. So we can find out the area of triangle BPF, and in this way we will find out also the area of the green shape. Okay? as you can see, triangle BPF is an isosceles triangle. Triangle BPF is an isosceles triangle. Why? Because it has two angles that are equal to each other. Both those two angles, they are equal to theta. So I write down that triangle BPF is an isosceles triangle. I repeat again. Triangle BPF is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to theta. Those two angles. And we have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So I will read rule number 3 again. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle so triangle ABC, this triangle is an isosceles triangle. This is triangle ABC, and it is an isosceles triangle because it has two angles that are equal to each other. Both those two angles are equal to theta, and the base of this isosceles triangle, triangle ABC, is BC. So if we draw median to the base BC from the vertex A, and we will define the touching point between the median from A to the base BC as point O. So AO is the median to the base. The median to the base bisects the base. That is to say, BO equals to OC. If BO equals to X, then OC will be also equal to X. This is the definition of a median. The median bisects the base. So BO equals to OC. But according to rule number 3, it is not only bisects the base BC, but it is also perpendicular to the base BC. That is to say, AO is perpendicular to the base BC. It means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So I will repeat again, according to rule number 3, if we have an isosceles triangle, triangle ABC is an isosceles triangle because of the fact that those two angles are equal to each other, they are both equal to theta, then the median to the base BC is not only bisects the base, but it is also perpendicular to the base BC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. And we can actually implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle, triangle BPF, and the median and the base of the isosceles triangle, triangle BPF, is BP. So the median to the base, that is to say FE, FE is the median to the base. Why? Because it bisects the base BP into two equal parts. BE equals to 7 units and EP also equals to 7 units. So the median to the base bisects the base into two equal parts. And according to rule number 3, it is not only bisects the base, but it is also perpendicular to the base BP. That is to say, this angle equals to 90 degrees, and this angle also, it is a right angle, it equals to 90 degrees. Okay, according to number 3, the median FE to the base BP of the isosceles triangle, triangle BPF, is perpendicular to the base BP. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So if this angle is a right angle, it equals to 90 degrees, then the green triangle, triangle BEF, is a right triangle. So we focus on this green right triangle, triangle BEF. In triangle BEF, according to Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We will get that the hypotenuse in this green triangle, triangle BEF, is BF, and the square of the hypotenuse is BF squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BE squared plus EF squared. I repeat again, in the right triangle, triangle BEF, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to BE square plus EF square. Okay? And BF, the hypotenuse BF equals to 9 units. It is given us in the question that BF equals to 9 units. So if BF is 9, then BF square is 9 squared. 9 squared is 81. And it equals to BE square. It is given us the question that BE equals to 7 units. So BE square is 7 square. 7 square is 49. Plus EF square. EF is the missing variable, so we will leave it as it is. EF square. So in conclusion, we found out that 81 equals to 49 plus EF square. We will subtract 49 from this equation, equation number 1, and we will get that 81 minus 49 is 32, and it equals to EF square. (32) equals to EF square. We will take a root out of this equation, equation number 1, and we will get that EF equals to the square root of 32, and 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that according to equation number 1, EF equals to 4 times square root of 2 units. EF equals to 4 times square root of 2 units. So now we can easily find out the area of this isosceles triangle, triangle BPF, because we know that the base of the isosceles triangle is BP, and it equals to 7 plus 7, and the height to the base is EF, that equals to 4 times 2 units. So the area of the isosceles triangle, triangle BPF, is equal to the base of the triangle times the height to the base over 2. I will repeat again. The area of the isosceles triangle, triangle BPF, equals to the base of the triangle times the height to the base over 2. So the area of the isosceles triangle, triangle BPF is equal to the base of the triangle, the isosceles triangle, triangle BPF. The base is BP, times the height to the base. The height must create 90 degrees with the base, and the height, it is actually EF, over 2. I will repeat again. The area of the isosceles triangle BPF equals to the base of the isosceles triangle BPF, that is BP, times the height to the base. The height is EF over 2. But we have already found out that BP equals to 7 plus 7, that is to say BP equals to 14 units. And EF equals to 4 times square root of 2 units over 2. So the area of the isosceles triangle BPF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so I'll write it down. The area of the isosceles triangle BPF is equal to 14 over 2 is 7. 7 times 4 times square root of 2. And 7 times 4 is 28. So in conclusion, we found out that the area of the isosceles triangle BPF, that is also the area of the green shape, is equal to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I will repeat again. We found out that the area of the isosceles triangle BPF, that is also the area of the green shape. Why? Because the area of the isosceles triangle, as you remember, it equals to x plus y. It is exactly the area of the green shape that it is also equals to x plus y. So the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will use rule number 2. Actually, we know that AB is parallel to CD because of the fact that the opposite sides of a rectangle are parallel to each other. And if AB is parallel to DC, then AB will be parallel to part of DC. That is to say, AB will be also parallel to FC, that is part of DC. So AB is parallel to FC. Again, AB is parallel to FC. And those two angles, they are defined as alternating angles that are located between the parallel lines AB and FC, therefore they are equal to each other. That is to say, this angle is equal to theta plus theta is 2 theta, and it equals to this angle, so this angle will be also equal to 2 theta. I repeat again, according to rule number 2 that I mentioned in method 1, those two angles that are located between the parallel lines AB and FC, they are equal to each other. So if this angle equals to 2 theta, then this angle will be also equal to 2 theta. Okay? And we also know that all the angles inside the rectangle are equal to each other, so all the angles inside rectangle ABCD are right angles, so this angle, it is a right angle, it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees. And this angle, it is a right angle, it equals to 90 degrees. Okay? So, in the next step, we will focus on this right triangle, triangle ABE. I will draw again the right triangle, the right green triangle, triangle ABE. Okay? It is given us in the question that AE equals to ED. So we define AE as X. That is to say AE equals to X according to our definition. And if AE equals to X, then ED will be also equal to X because of the fact that AE equals to ED. So I draw again the right triangle, triangle ABE. We know that EB equals to 7 units and AE is equal to X units according to our definition. So here you can see from the drawing that sinus theta equals to X over 7. Sinus theta equals to X over 7. So this is in the right triangle, triangle ABE. And if we focus on the lower right triangle, triangle FBC, in the right triangle, triangle FBC, sinus 2 theta equals to BC over 9. But we also know that the opposite sides of a rectangle are equal to each other. That is to say AD equals to BC. And AD is equal to X plus X according to our definition. That is to say AD equals to 2X. Therefore, BC will be also equal to 2X because of the fact that AD is equal to BC. Okay, so sinus 2 theta equals to 2X over 9. repeat again. In the lower right triangle FBC, sinus 2 theta equals to 2x over 9. But we have the trigonometric identity that states that sinus 2 theta equals to 2 sinus theta cosine theta. So according to this trigonometric identity, we can substitute sinus 2 theta in this equation number 2, by 2 sine theta cosine theta. So we will do it now, and we will get that according to equation number 2, so sinus 2 theta equals to 2 sinus theta cosine theta according to this trigonometric identity. And according to equation number 2, sinus 2 theta equals to 2x over 9. And according to equation number 1, this equation sinus theta equals to x over 7. So we can substitute sinus theta in equation number 2, this equation, by x over 7. Because sinus theta equals to x over 7 according to equation number 1. So we will do it now, and we will get that 2 sinus theta is x over 7, times cosine theta equals to 2x over 9. Here we have 2x on both sides of equation number 2, so 2x will get cancelled. And what is left from equation number 2 after we cancel 2x? What is left? This is actually cosine theta over 7 equals to 1 over 9. Here we will multiply this equation number 2 by 7, and we will get that according to equation number 2, cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9. So we can write here in a new page that cosine theta equals to 7 over 9 according to equation number 2. Cosine theta equals to 7 over 9. So what is the meaning of the equality that cosine theta equals to 7 over 9? It means that we have a right triangle with angle theta and the hypotenuse is equal to 9 units, and the side that is near angle theta equals to 7 units. Okay, and the side that is in front of angle theta is the missing side, so we define it as S. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say s squared plus 7 squared equals to 9 squared. So s squared plus 7 squared is 49. It equals to 9 squared. 9 squared is 81. Here we will subtract 49 from this equation and we will get that s squared equals to 81 minus 49 is 32. Here we will take a root out of this equation and we will get that s equals to the square root of 32 and 32 is 16 times 2, so I write it down. And the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2. So we can write here that s equals to 4 times square root of 2. So what is the value of sinus theta? If we look in this drawing, the value of sinus theta, it is actually equal to 4 times square root of 2 over 9. So we will multiply this equation by 9 and we will get that. But before that, we have already found out that sinus theta is equal to x over 7. Here, sinus, so we found out that sinus theta equals to 4 times square root of 2 over 9. And we have equation number 1. According to equation number 1, sinus theta equals to x over 7. So we can substitute sinus theta by x over 7 in this equation. And it equals to 4 times square root of 2 over 9. Here we will multiply this equation by 7 and we will get that x equals to 7 times 4 is 28 times square root of 2 over 9. So we found out that x equals to 28 times square root of 2 over 9. Here we can also write down that x equals to 28 times square root of 2 over 9. So if x is equal to 28 times square root of 2 over 9, then 2x, it is to say x plus x, 2x will be equal, AD equals to 2x, so 2x will be equal to 56 times square root of 2 over 9. And we also know that the opposite sides of a rectangle are equal to each other. that is to say AD equals to BC. So if AD equals to 56 times square root of 2 over 9, then BC will be also equal to 56 times square root of 2 over 9. And we'll focus on the right triangle, triangle ABE. You can see here that cosine theta equals to AB over 7. Again, in this right triangle, triangle ABE, cosine theta equals to AB over 7. I will repeat again. In the right triangle, triangle ABE, you can see from the drawing that cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta in this equation by 7 over 9. So we'll do it now, and we will get that 7 over 9 equals to AB over 7. Here we will multiply this equation by 7, and we will get that AB equals to 7 times 7 is 49. So AB equals to 49 over 9. So we can write here that AB equals to 49 over 9. And because of the fact that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC, but AB equals to 49 over 9, therefore DC will be also equal to 49 over 9. So DC equals to 49 over 9. In the next step, we will focus on the lower right triangle, triangle BFC. In triangle BFC, cosine 2 theta, you can see here, cosine 2 theta equals to FC over 9. I will repeat again. In the right triangle, triangle BFC, cosine 2 theta equals to FC over 9. So we will multiply this equation by 9, and we will get that FC FC equals to 9 times cosine 2 theta. But we have the trigonometric identity that states that cosine 2 theta equals to 2 cosine square theta minus 1. So according to this trigonometric identity, we can substitute cosine 2 theta in this equation by 2 times cosine square theta minus 1. So we'll do it now, and we will get that FC equals to 9, and cosine 2 theta according to this trigonometric identity it equals to 2 times cosine square theta minus 1. And we have already found out that cosine theta equals to 7 over 9. If cosine theta equals to 7 over 9, then cosine square theta will be equal to 7 over 9 squared. So FC equals to 9 times 2 times 7 over 9 squared minus 1. So FC equals to 9 times 2, 7 squared is 49, over 9 squared is 81, and minus 1 is minus 81 over 81. Here 2 times 49 is 98, so I'll write it down. So FC equals to 9 times 98 minus 81 over 81. So we found out that FC equals to 9 times 98 minus 81 over 81. 98 minus 81 is 17, so I'll write it down. We found out that FC equals to 9 times 17 over 81. So here we will divide the numerator and the denominator in this expression by 9, and we will get that in conclusion FC equals to 9 over 9 is 1. So in the numerator we left only with 17, and 81 over 9 is 9. So in conclusion, we found out that FC equals to 17 over 9. FC equals to 17 over 9. So we can write here that FC equals to 17 over 9, and what is the value of DF? DF equals to DC minus FC. Again, DF equals to DC minus FC. DF equals to DC minus FC. It is very simple. You can see it from the drawing. Again, DF equals to DC minus FC. So DF equals to DC is 49 over 9. minus FC. We already found out that FC equals to 17 over 9. So in conclusion, we found out that DF equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32, so I'll write it down. So DF equals to 32 over 9. We found out that DF equals to 32 over 9. So we can write here that DF equals to 32 over 9. So we actually have all the sides, the values of all the sides of trapeze ABDF, that is also the area of the green shape. So we will find out the area of trapeze ABDF according to the formula that the area of any trapeze is equal to the sum of its sides, that is to say it equals to AB plus DF times the height is AD over 2. I'll repeat again, the area of trapeze ABDF, that is also the area of the green shape that we are looking for, it equals to the sum of its sides, that is to say AB plus DF times the height, that is AD over 2. And we have already found out that AB equals to 49 over 9. Plus DF equals to 32 over 9 times the height AD equals to 56 times square root of 2 over 9 all divided by 2. Okay, so the area of trapeze ABDF, that is also the area of the green shape, equals to this expression. 49 plus 32 is 81. So I'll write it down. So the area of trapeze ABDF, that is the area of the green shape also, equals to 81 over 9 times 9 times 56 times square root of 2 all divided by 2. Okay, so the area of trapeze ABDF equals to, here we have 81, and in the denominator we have 9 times 9 is also 81. 81 over 81 is 1, so this expression will get cancelled, and we left only with 62 times square root of 2 over 2 and 56 times square root of 2 over 2. 56 over 2 is 28. So we found out that the area of trapeze ABDF, that is also the area of the green shape, is equal to, again, 56 over 2 is 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, I repeat again. We found out that the area of the green shape, according to the second method, it equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. Okay, so we finished with the second method. In the next step, I will present to you how to find out the area of this green shape according to a third method. In the third method, we will draw perpendicular from point E to BF. So this angle is a right angle, it equals to 90 degrees, and this angle is also equals to 90 degrees according to our construction. And we will define the touching point between the perpendicular from point E to BF as point M. In the next step, we will prove that those two right green triangles can go into each other. First of all, we know that all the angles inside the rectangle are right angles. So this angle is a right angle, it equals to 90 degrees. This angle, it is also a right angle, it equals to 90 degrees. And this is also a right angle, that is to say it equals to 90 degrees. And here we will prove that those two right triangles can go into each other. So we will focus on the right triangle, triangle ABE. And on the right triangle, right green triangle, triangle EBM, this right green triangle, and we will prove that those two right triangles can go into each other. First of all, we know that those two angles, they are equal to each other, they are both equal to theta according to what is given us the question. So angle ABE, this angle, is equal to angle EBM, this angle, and both angles, both those two angles are equal to theta according to what is given us in the question. Again, angle ABE equals to angle EBM, and both angles are equal to theta. And those two angles, they are also equal to each other, they are both right angles, so I write it down, angle BAE is equal to angle BME, and both those two angles are equal to 90 degrees. I repeat again, angle BAE equals to angle BME, and they are both equal to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. So this angle is angle AEB, and it's equal to this angle, angle BEM, they are equal to each other, those two angles are equal to each other, according to third angle theorem. I repeat again, angle AEB is equal to angle BEM, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we actually prove that those two angles in triangle ABE congruent to those two angles in triangle EBM. So we have here two pairs of angles that congruent in those two triangles. Therefore, the third pair of angles, those two angles that are defined as the third pair of angles, must also congruent. That is to say, angle BEM must be equal to angle BEA. Okay? Or angle AEB equals to angle BEM according to third angle theorem. And we also know that BE is a common side, it belongs to both triangles, so we can write down that BE equals to BE. It's a common side that belongs to both triangles. BE equals to BE. It's a common side that belongs to both triangles. I'll repeat again. BE equals to BE, it is a common side that belongs to both triangles. So we actually proved that those two right green triangles can congruent to each other according to angle side angle rule. So I'll write it down. Here you can see we have two angles, those two angles, and the side that included between those two angles congruent to those two angles and the side that included between them in this right triangle. So those two triangles congruent to each other according to angle side angle rule. That is to say, triangle ABE is congruent to triangle EBM according to angle side angle rule. Okay, I'll repeat again. Triangle ABE congruent to triangle EMB according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM. AB equals to BM. I'll repeat again. AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AB and BM will be equal to each other. And if we define AB as Y, then BM will be also equal to Y because of the fact that they are equal to each other. So AB equals to BM equals to Y. And we also can conclude from the fact that those two triangles can go into each other that AE equals to EM. AE equals to EM according to the same rule that corresponding sides in congruent triangles are equal to each other. And if we define AE as x, then EM will be also equal to x because they are equal to each other. So AE equals to EM equals to x according to our definition. And we also know that AE is equal to ED. So if AE equals to x, then ED will be also equal to x. And here we know that BF is equal to 9 units. BF is equal to 9 units according to what is given us in the question. And we found out that BM equals to y. So MF equals to BF minus BM. Again, MF equals to BF minus BM. That is to say, MF equals to BF, that is 9 units, minus BM, that is y. In conclusion, MF equals to 9 minus y. Okay? In the next step, we will join together points E and F by a straight line. And we will prove that those two right triangles can go into each other. Again, we will prove that the right triangle, triangle EDF, congruent to the right triangle, triangle EFM. This right triangle so first of all, we just right now proved that EM is equal to ED is equal to X. EM equals to ED and they are both equal to X. I'll repeat again. EM equals to ED equals to X. And EF is a common side that belongs to both triangles, so EF equals to EF is a common side that belongs to both triangles. I'll repeat again. EF equals to EF is a common side that belongs to both triangles. And we have those two angles, they are right angles, therefore they are equal to each other. So angle EMF is equal to angle EDF. And they are both equal to 90 degrees. You can see from the drawing. So angle EMF equals to angle EDF and they are both equal to 90 degrees. So by proving those three things, we actually proved that those two right triangles, that is to say triangle EDF and triangle EFM, can go into each other according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. So I'll repeat on rule number 5 again. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. Okay, and we actually proved that the hypotenuse EF and the perpendicular EM in the right triangle EMF congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. So we can write down that triangle EDF congruent to triangle EFM according to rule number 5. Okay? And from the fact that those two triangles can go into each other, we will conclude that MF equals to DF, MF equals to DF, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say MF and DF, will be equal to each other. But we know that MF equals to 9 minus Y, so we can write down that MF equals to 9 minus Y. And from this equation, we will conclude that DF also equals to 9 minus Y. DF equals to 9 minus Y. So we can write here that DF equals to 9 minus Y. Okay. And we also know that the opposite sides of a rectangle are equal to each other, that is to say AB equals to DC. But if AB equals to Y, then DC will be also equal to Y, because they are equal to each other. So DC will be also equal to Y. According to the rule that the opposite sides of a rectangle are equal to each other, so it equals to Y. And here you can see that FC is equal to DC minus DF. I repeat again. FC equals to DC minus DF. So FC equals to DC, DC is Y, minus DF, DF is 9 minus Y. So in conclusion, we found out that DC equals to Y minus Y, Y minus 9 minus Y. We will open the brackets in this equality and we will get that FC equals to Y minus 9 minus Y is plus Y. So in conclusion, we found out that FC equals to Y plus Y is 2Y minus 9. FC equals to 2Y minus 9. FC equals to 2Y minus 9. And because of the fact that the opposite sides of a rectangle are equal to each other, that means that AD equals to BC, but AD equals to x plus x, that is to say AD equals to 2x, therefore BC will be also equal to 2x. Okay? So we will focus on the right triangle, triangle ABE, on this right triangle, triangle ABE. According to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we will get that x squared plus y squared equals to 7 squared. X squared plus y squared equals to 7 squared. I'll repeat again. In the right green triangle, triangle ABE, according to the Pythagoras theorem, x squared plus y squared equals to 7 squared. That means that x squared plus y squared equals to 49. In the next step, we will focus on the lower right triangle, triangle BFC. On the right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle BFC is BF, and we know that BF equals to 9 units. So BF squared will be equal to 9 squared. 9 squared is 81. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to FC squared plus BC squared. I will repeat again. In the right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, 81 equals to FC squared plus BC squared. But we have already found out the value of FC. FC equals to 2y minus 9. So we get that 81 equals to 2y minus 9 squared plus BC squared. BC equals to 2x, so BC squared will be equal to 4x squared. So in conclusion, we found out that According to equation number 2, 81 equals to 2y minus 9 squared plus 4x squared. We will open the brackets on this side of equation number 2 and we will get that 81 equals to 4y squared, 2y minus 9 squared it equals to 4y squared plus 81 minus 36y plus 4x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. So we get that 0 equals to 4. We take a common factor 4. We take out a common factor 4 from 4x squared and 4y squared. So in the brackets we will have x squared plus y squared minus 36y. Here we will add 36y to this equation, equation number 2. And we will get that 36y equals to 4 times x squared plus y squared. So here we have x squared plus y squared, but according to equation number 1, x squared plus y squared equals to 49. So we can substitute x squared plus y squared in equation number 2 by 49. Because it equals to 49 according to equation number 1. We will do it now and we will get that 36y equals to 4 times x squared plus y squared is 49. Here we will divide this equation, equation number 2 by 4 and we will get that 36 over 4 is 9, so here we will have 9y equals to 4 over 4 is 1, so what is left is 49. So, in conclusion, we found out that according to equation number 2 that 9y equals to 49. We will divide this equation, equation number 2 by 9 in order to get the value of y. And we will find out that y equals to 49 over 9. So we can write here that here, okay, here we got that according to equation number 2, y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So we can substitute y squared in equation number 1 by 49 over 9 from equation number 2, because y squared equals to 49 over 9 according to equation number 2. So we will do it now and we will get that x squared plus y squared according to equation number 2, y squared is 49 over 9 squared. And it equals to 49. Here we will subtract from this equation, equation number 1, 49 over 9 squared, and we will get that x squared equals to 49 is 7 squared minus 49 over 9 squared, and we have the algebraic identity that states that a squared minus b squared equals to a plus b, a minus b. We will use this algebraic identity in order To simplify our expression, equation number 2, so our expression is x squared equals to 7 squared minus 49 over 9. Here in our expression b squared is 0, a equals to 7, and b equals to 49 over 9. So we will get that x squared equals to a plus b times a minus b. A plus b, a is 7, b is 49 over 9, so it is 7 plus 49 over 9 times a minus b is 7 minus 49 over 9. Okay? Here we will multiply 7 by 9 and then we will divide it by 9 in order to have a common factor with 49 over 9, and we will get that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. So we got that x squared equals to 63 plus 49 is 112 over 9, and 63 minus 49 is 14 over 9, and we know that 112 is 8 times 14, so we will substitute 112 by 8 times 14. 8 times 14 over 9 times 14 over 9. Here we will substitute 8 by 2 times 2 times 2, and we will get that according to equation number 2, x squared equals to 2 times 2 times 2, that is 8, times 14 times 14, over 9 times 9, so in conclusion, we found out that x squared equals to 2 times 2 times 2 times 14 times 14 over 9 times 9. We take a root out of this equation, equation number 2, and we will get that x equals to, according to equation number 2, x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9, and we know that the square root of 2 times 2 is 2. The square root of 14 times 14 is 14. And the square root of 9 times 9 is 9. So inside the bracket, inside the root, we left only with 2. So in conclusion, we found out that x equals to 2 times 14 times square root of 2 over 9. 2 times 14 is 28, so I write it down. So in conclusion, we found out that according to equation number 2, x equals to 28 times square root of 2 over 9 units. And we already found out that y equals to 49 over 9. After we found out the value of x and y, it is very easy to find out the area of the green shape, that is also the area of trapeze ABDF. So the area of trapeze ABDF, the area of any trapeze, is equal to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. I'll repeat again. The area of trapeze ABDF, that is also the area of the green shape, equals to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. But we have already found out that AB equals to y and DF equals to 9 minus y, and AD equals to 2x. So in conclusion, we found out that the area of the green shape, that is also the area of the trapeze ABDF, equals to AB, that is y, plus DF, that is 9 minus y, times AD, that is 2x. Here y minus y is 0, and 2 over 2 is x. So in conclusion, we found out that the area of the green shape, that is also the area of trapeze ABDF, equals to 9x. So I write it down. The area of the green shape, and that is also the area of trapeze ABDF, equals to 9x, and we already found out that x equals to 28 times square root of 2 over 9, so I write it down. So it is 9 times 8, that equals to 28 times square root of 2 over 8. Here 9 over 9 is 1, so 9 will get cancelled. And we found out that the area of trapeze ABDF, that is also the area of the green shape, according to the third method, it equals either to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I repeat again. We found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the third method. Now I'll summarize the lecture. Actually, we wanted to find out the area of this green shape, and we found it in 3 different methods. In the first method, In the first method, we did a construction. We extended side CD and side BE until they intersect with each other at point P. Point P is the intersection point between extended CD and extended BE. We know that CD or DC is one side of rectangle ABCD, therefore it is absolutely a straight line. So, and then when we extended the straight line DC by straight line, it will be still a straight line. So CP is a straight line. Okay, CP is a straight line. So I can write down that CP is a straight line. And we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So, according to rule number 1, if you focus on this side of the straight line PC, then at point D, the sum of its angles must be equal to 180 degrees. Which angles we have at point D on this side of PC? We have here this angle that is angle X, according to our definition, plus this angle that is a right angle. The sum of those two angles must be equal to 180 degrees according to rule number 1. So X plus 90 degrees must be equal to 180 degrees according to rule number 1. We subtracted 90 degrees from this equation and we got that angle X equals to 90 degrees. That is to say, this angle is a right angle. It equals to 90 degrees. Then we know also that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DC. And we have already found out that DC or CD and CP is one straight line. CD and CP is one straight line. Okay? Or they sit on the same straight line. It is one straight line. So if AB is parallel to DC, then AB will be also parallel to CP, that is the same straight line. Okay? So AB will be also parallel to CP. Okay? And we have those two angles are defined as alternating angles, and they are located between the parallel lines AB and CP. Therefore, they are equal to each other according to rule number 2. Here, we know that AB is parallel to PC or CP. AB is parallel to PC, and according to rule number 2, alternating angles between parallel lines are equal to each other. That is to say, those two angles are alternating angles and they are located between the parallel lines AB and PC, therefore they are equal to each other according to rule number 2. That is to say, angle ABE equals to angle EPD according to rule number 2. But we know that angle ABE equals to theta according to what is given us in the question. Angle AB equals to theta, so I can write here that angle AB equals to theta, and from this equality we will conclude that angle EPD also equals to theta. So this angle equals to theta, angle EPD. Then we proved that those two right angles can go into each other. Why they can go into each other? First of all, ABE equals to EPD equals to theta. Those two angles are equal to each other according to what is given as the question. They are both equal to theta. And we have those two angles, the right angles, both right angles, and they're equal to each other. So angle BAE equals to angle PD equals to 90 degrees. And those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. Okay? And we also know that AE equals to ED according to what is given us in the question. AE equals to ED. And therefore, we actually proved that the right green triangle ABE can go into the right green triangle it can go into the right triangle PDE according to angle side angle rule. And what is angle side angle rule? Angle side angle rule says that if two angles and the side that included between those two angles in one triangle can go and correspondingly to two angles at the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. And we actually proved that those two angles and the side that included between them, that is to say AE, in the green right triangle ABE, can go into those two angles and the side that included between those two angles, that is to say ED, in triangle PDE. Therefore, we proved that those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that BE equals to EP. Okay, BE equals to EP. BE equals to EP according to the rule that corresponding sides in congruent triangles are equal to each other. But we know it is given us the question that BE equals to 7. BE equals to 7 according to what is given as the question. From this equation, from this equality, we will conclude that EP also equals to 7 units. EP also equals to 7 units. And we define the area of quadrilateral EBFD as Y. The area of quadrilateral EBFD is defined as Y. And, okay, the area of quadrilateral EBFD is defined as Y. We define the area of this green right triangle ABE as X. The area of triangle AB equals to X. So the area of the green shape equals to X plus Y. X plus Y. And we know that those two triangles can go into each other. Therefore, they have also the same area. So if the area of triangle ABE equals to X, then the area of triangle PED will be also equal to X. Okay, so the area of triangle PED equals to X. So, and the area of triangle PBF equals to X plus Y, exactly as the area of the green shape. So we actually note that the area of the green shape equals to X plus Y exactly as the area of triangle BPF, that is also equals to X plus Y. So we will find out the area of triangle BPF, and this way we will find out the area of the green shape because they have exactly the same areas. Okay? So we will find out the area of this triangle PBF. Okay? And we know that triangle PBF is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to theta. And according to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. What is the meaning of rule number 3? The meaning of rule number 3 is that if we have the isosceles triangle ABC, triangle ABC is an isosceles triangle because it has two angles that are equal to each other. They are both equal to theta. And the base of the isosceles triangle ABC is BC. So if from the vertex A we will draw the median to the base BC, then the median according to its definition, bisects the base into two equal parts. That is to say, BO equals to OC, so, and if BO equals to X, then OC will be also equal to X. That is the definition of the median. It bisects the base, okay? And according to rule number 3, it is not only, the median is not only, the median to the base, it is not only bisects the base, but it is also perpendicular to the base BC, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. So the median to the base in an isosceles triangle is perpendicular to the base. We can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle PBF, and the base is BP. The median to the base EF bisects the base BP into two equal parts. That is to say, BE equals to EP equals to 7 units. But it is not only bisect the base BP, but it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So if this angle equals to 90 degrees, then the green triangle BEF is a right triangle. We can implement the Pythagoras theorem in the right green triangle BEF. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BF, the square of the hypotenuse is BF squared. It equals to the sum of the squares of the perpendiculars, that is to say, it equals to BE squared plus EF squared. BF equals to 9 units, this is given us in the question, so BF squared is 9 squared, 9 squared is 81. BE equals to 7 units, it is given us in the question, so BE squared equals to 7 squared, 7 squared is 49. We subtracted 49 from this equation number 1, and we got that 81 minus 49 is 32, 32 equals to EF squared. Then we took a root out of equation number 1, and we found out that EF equals to the square root of 32. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2 units. EF equals to 4 times square root of 2 units. Now it is very easy to find out the area of a triangle PBF, the isosceles triangle PBF, because we know the size of the base BP is 7 plus 7, that is to say 14, and the height to the base is EF, that equals to 4 times square root of 2 units, and the area of any triangle equals to the base times the height over 2. So the area of triangle PBF equals to the base, that is BP, times the height, that is EF, over 2. We've already found out that BP equals to 14 and EF equals to 4 times square root of 2 units. So in conclusion, we found out that the area of triangle BPF equals to 14 times 4 times square root of 2 over 2. Here 14 over 2 is 7. So in conclusion, we found out that the area of the isosceles triangle BPF equals to 7 times 4 times square root of 2. So the area of the isosceles triangle BPF, that is the area of the green shape, equals to either 28 times square root of 2 square units, so in terms of numbers, it equals to 39.6 square units. So we finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. According to the second method, we used rule number 2. We know that the opposite sides of a rectangle are equal to each other, that is to say AB, the opposite sides of a rectangle are parallel to each other, that is to say AB is parallel to DC. But if AB is parallel to DC, AB will be also parallel to the part of DC, that is to say it will be parallel also to FC, that is part of DC. So we know that AB is parallel to FC, and those two angles are defined as alternating angles that are located between the parallel lines AB and FC, therefore they are equal to each other. Okay? And this angle equals to 2 theta, and it equals to this angle, so this angle will be also equal to 2 theta, according to rule number 2. So this angle equals to 2 theta, and we know that all the angles inside a rectangle are right angles, so this angle, this angle, and this angle are right angles. And then we focused on the right triangle, triangle ABE, on the right triangle, triangle ABE. I drew again the right triangle, triangle ABE. We defined AE as X, and because of the fact that AE equals to ED, according to what is given us in the question, then if AE equals to X, then ED will be also equal to X. So AE equals to X, BE equals to 7 units, it's given us in the question. BE equals to 7 units. And this angle is angle theta. So you can see from the drawing that sinus theta equals to x over 7. And if we focus on the lower right triangle, triangle BFC, this triangle here, we know that the opposite sides of a rectangle are equal to each other. That means that AD equals to BC, but we know that AD equals to x plus x. That is to say it equals to 2x. So if AD equals to 2x, then BC will be also equal to 2x. So here, sinus 2 theta equals to 2x over 9. According to equation number 2, if we focus on the right triangle, triangle BFC, sinus 2 theta equals to 2x over 9. But we have the trigonometric identity that states that sinus theta equals to 2 sinus theta cosine theta. So we can substitute sinus 2 theta in equation number 2 by 2 sin theta cosine theta. We did it, and we got that 2 sin theta cosine theta according to equation number 2 equals to 2x over 9. And we have already know that according to equation number 1, sin theta equals to x over 7. So we can substitute sin theta in equation number 2 by x over 7, according to equation number 1. We did it, and we got that 2 times sin theta is x over 7 times cosine theta equals to 2x over 9. We have 2x on both sides of equation number 2, so 2x will get cancelled. And we left only with cosine theta over 7 equals to 1 over 9. We multiplied the equation number 2 by 7, and we got that cosine theta equals to 7 over 9. Okay, we found out that cosine theta equals to 7 over 9. Then we know what is the meaning of cosine theta equals to 7 over 9. It means that we have a right triangle with the hypotenuse that equals to 9 units, and the angle, the side that is near angle theta equals to 7 units. And the side that is in front of angle theta is the missing side. We'll find it according to the Pythagoras theorem. S squared plus 7 squared equals to 9 squared. S squared plus 7 squared is 49, 9 squared is 81. 81 minus 49 is 32, so S squared equals to 32. We took a root out of this equation, and we got that S equals to square root of 32. 32 is 16 times 2, the square root of 16 is 4, so in conclusion we found out that AS equals to 4 times 2. So here you can see that sine theta equals to 4 times square root of 2 over 9. Okay, but we have already found out that here, according to equation number 1, we found out that sine theta equals to x over 7, so we can substitute sine theta in this equation by x over 7, because sine theta equals to x over 7 according to equation number 1. So we did it and we got that x over 7 equals to 4 times square root of 2 over 9. We multiplied this equation by 7 and we got that x equals to 7 times 4 is 28. So x equals to 28 times square root of 2 over 9. So here we can write down that x equals to 28 times square root of 2 over 9. Here is also x is 28 times square root of 2 over 9. And 2x will be equal to 56 times square root of 2 over 9. And the opposite sides of a rectangle are equal to each other. So if AD is 2x, then BC will be also equal to 2x. That is to say BC equals to 2x, that is 56 times square root of 2 over 9. Okay? Then we focus on the right triangle ABE. We know that in the right triangle ABE, cosine theta, so you can see here, cosine theta equals to AB over 7. Cosine theta equals to AB over 7 in the right triangle ABE. But we have already found out that cosine theta equals to 7 over 9. So we can substitute cosine theta in this equation by 7 over 9. We did it and we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we got that AB equals to 49 over 9. Here AB equals to 49 over 9, but we know that the opposite sides of a rectangle are equal to each other. That means that AB equals to CD. And if AB equals to 49 over 9, then CD will be also equal to 49 over 9. Okay? So in the right triangle, the lower right triangle BFC, cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9. We multiplied this equation by 9 and we got that FC equals to 9 times cosine 2 theta. And according to the trigonometric identity, cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta by 2 cosine square theta minus 1. We did it and we got that FC equals to 9 times 2 times cosine square theta minus 1. And we have already found out that cosine theta equals to 7 over 9. So if cosine theta equals to 7 over 9, then cosine square theta will be equal to 7 over 9 square. Okay, so we substituted cosine square theta by 7 over 9 square. And we got that FC equals to 9 times 2, 7 over 9 square minus 1. So FC equals to here 7 over 9 square, 7 square is 49 and 9 square is 81. Minus 1 can be substituted by minus 81 over 81. We did it and we got this expression. Here 9 times 49 is 98. So in conclusion, we found out that FC equals to 9 times 98 minus 91 over 81. 98 minus 81 is 17. So in conclusion, we got that FC equals to 9 times 17 over 81. We divided the numerator and the denominator in this equation by 9. 9 over 9 is 1, so we left only with 17 in the numerator. And in the denominator, 81 minus 9 is 9. So in conclusion, we found out that FC equals to 17 over 9. So we can write here that FC equals to 17 over 9. And what is the value of DF? DF equals to DC minus FC. DF equals to DC minus FC. Here, DF equals to DC minus FC, but we already found out that DC equals to 49 over 9 and FC equals to 17 over 9. So in conclusion, we found out that DF equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that DF equals to 39 over 9. So we can write here that DF equals to 32 over 9. Then we actually have all the sides of trapeze ABDF, therefore we can calculate the area of trapeze ABDF according to the formula that the area of any trapeze equals to the sum of its sides. That is to say, it equals to AB plus DF times the height, that is AD, over 2. AB plus DF, the sum of its sides, times the height, that is AD, over 2. We have already found out that AB equals to 49 over 9. DF equals to 32 over 9. And the height AD equals to 56 times square root of 2 over 9, all divided by 2. Here, 49 plus 32 is 81. So, and we have also 56 times square root of 2 over 9. And here we have 9 times 9. 9 times 9 is 81. So 81 over 81 is 1. So this expression will get cancelled, and we left only with 56 times square root of 2 over 2. 56 over 2 is 28. So the area of trapeze ABDF, that is also the area of the green shape, equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method, and then I presented to you how to find out the area of this green shape according to a third method. In the third method, we did the construction. We actually from point E, we drew perpendicular to BF. So this angle equals to 90 degrees and this angle equals to 90 degrees. And we defined the touching point between the perpendicular from point E to BF as point M. Then we proved that those two right angles can go into each other. You know that all the angles inside a rectangle are right angles, so this angle, this angle, this angle are right angles. We proved that those two right angles can go into each other. That is to say, we proved that the right green triangle ABE can go into the right triangle EBM. Why? Because we have those two angles, they are equal to each other, they are both equal to theta. So angle ABE equals to angle EBM equals to theta, according to what is given as the question. And we also know that those two angles, they are both right angles, therefore they are equal to each other. Angle BAE equals to angle EMB equals to 90 degrees. And we know those two angles, they are equal to each other according to third angle theorem. What is third angle theorem? If two angles in one triangle can go into two angles in another triangle, then the first pair of angles must also can go in. For that reason, so we have those two angles can go in triangle ABE, can go to those two angles in triangle ABEM. Therefore, those first pair of angles must also can go, that is to say angle BEM must be equal to angle AEB. Okay, so angle AEB must be equal to angle BEM according to third angle theorem. And we also know that BE is a common side that belongs to both triangles, so BE equals to BE is a common side that belongs to both triangles. So we actually proved that triangle ABE, the right green triangle ABE, is congruent to the right triangle EMB according to angle side angle rule. Okay, then from the fact that those two triangles can go into each other, we will conclude that AB is equal to BM, AB equals to BM, and AX equals to EM. AB equals to EM, and we defined AB as Y, therefore BM will be also equal to Y, and AE equals to EM. We defined AE as X, therefore EM will be also equal to X. So here AB equals to Y and BM also equals to Y, and AE equals to X and EM also equals to X, and because of the fact that AE equals to ED, then if AE equals to X, then ED must be also equal to X. Then we join points E and F together by a straight line and prove that those two right triangles can go into each other. We proved the triangle EDF, the right triangle EDF can go into the right triangle EFM. Why they can go into each other? First of all, we know that EM equals to ED equals to X. EM equals to ED equals to X. EF equals to itself. It is a common side that belongs to both triangles. So EF equals to EF is a common side that belongs to both triangles. And angle, those two angles, they are equal to each other. That is to say, they are both equal to 90 degrees. EMF equals to EDF equals to 90 degrees. So we actually proved that those two triangles, triangle EDF, can go into triangle EFM according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF can go into the hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. Triangle EDF can go into triangle EFM according to rule number 5. From the fact that those two triangles can go into each other, we will conclude that MF equals to DF. MF equals to DF. MF equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. But we know that MF equals to 9 minus Y. So from this equality we will conclude that DF also equals to 9 minus Y. Here DF equals to 9 minus Y. And we know that AB equals to Y. And the opposite sides of a rectangle are equal to each other. So if AB equals to Y, then DC will be also equal to Y. Okay? So what is the value of FC? FC equals to DC minus DF. FC equals to DC minus DF. We have already found out that DC equals to Y and DF equals to 9 minus Y. So FC equals to Y minus 9 minus Y. We open the brackets and we found out that FC equals to 2Y minus 9. FC equals to 2Y minus 9. And the opposite sides of rectangle are equal to each other. So AD equals to BC. But we know that AD equals to 2x. Therefore BC will be also equal to 2x. Then we implemented the Pythagoras theorem on the right triangle, right ring triangle. Triangle AEB, according to the Pythagoras theorem, x squared plus y squared equals to 7 squared. X squared plus y squared equals to 7 squared. That is to say, x squared plus y squared equals to 49. And we implemented the Pythagoras theorem on this lower right triangle, triangle BFC. The square of the hypotenuse is 9 squared. 9 squared is 81. And it equals to FC squared plus BC squared. Here 91 equals to FC squared plus BC squared. We have already know that FC equals to 2y minus 9, so FC squared equals to 2y minus 9 squared. BC equals to 2x, so BC squared will be equal to 4x squared. So in conclusion, we found out that 81 equals to 2y minus 9 squared plus 4x squared. We have 81. We open the brackets on this calculated the value of 2y minus 9 squared. It equals to 4y squared plus 81 minus 36y. We have here 81 on both sides of the equation number 2, so 81 will get cancelled. And we left off one with 0. That equals 4 is a common factor from 4yx and 4xy. Inside the brackets we have xy, x squared plus y squared minus 36y. X squared plus y squared equals to 49 according to equation number 1. So we can substitute x squared plus y squared in equation number 2 by 49 according to equation number 1. We did it and we got that here we have first of all we added 36y to this equation number 2 and we got that 36y equals to 4 times x squared plus y squared. We substituted x squared plus y squared by 49 and we got that 36y equals to 4 times 49. We divided equation number 2 by 4 and we got that 9, y equals to 49. We divided equation number 2 by 9 and we got that y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So we can substitute y squared in equation number 1 by 49 over 9 squared from equation number 2, because y squared equals to 49 over 9 according to equation number 2. We did it and we got that x squared plus y squared is 49 over 9 squared. That equals to 49. So x squared equals to 49 is 7 squared minus 49 over 9. And we simplify this expression according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. Here in our specific equation number 2, we know that b squared equals to 0, a equals to 7, and b equals to 49 over 9. So x squared equals to a plus b. A is 7, b is 49 over 9, so a plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. And here we multiplied 7 by 9 and then we divided by 9 in order to have a common factor with 49 over 9, and we got that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. 63 plus 49 is 112, all divided by 9, and 63 minus 49 is 14, is divided by 9. We know that 112 equals to 8 times 14, so we substituted 112 in equation number 2 by 8 times 14, and we got that x squared equals to 8 times 14 over 9 times 14. We know that 8 equals to 2 times 2 times 2, so we substituted 8 in this side of equation number 2 by 2 times 2 times 2, and we got that x squared equals to 2 times 2 times 2 times 14 over 9 times 9. We took a root out of this equation number 2, and we got that x equals to the square root of this expression. The square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. Inside the bracket, inside the root, we have only 2 left. So in conclusion, we found out that x equals to 2 times 14 over 9 times the root of 2. 2 times 14 is 28. So in conclusion, we found out that x equals to 28 times the root of 2 over 9, and we have already found out that y equals to 49 over 9. Now we can easily find out the area of the green shape. That is also the area of trapeze ABDF. The area of any trapeze equals to the sum of its sides. That is to say, here in this trapeze ABDF, it is AB plus DF times the height, that is AD over 2. So it is AB plus DF, the sum of its sides, times the height, that is AD over 2. We have already found out that AB equals to y and DF equals to 9 minus y, and AD equals to 2x, all divided by 2. So here y minus y is 0, and 2 over 2 is x. So in conclusion, we found out that the area of the green shape, that is also the area of triangle of trapeze ABDF, equals to 9x, because all the other expressions get cancelled. So the area of the green shape equals to 9x, but we have already found out that x equals to 28 times square root of 2 over 9. Okay, so we put the value of x inside x here, and we got that the area of the green shape equals to 9 times 28 times square root of 2 over 9. 9 over 9 is 1. So in conclusion, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. Okay? Thank you very much.